Good evening, everyone. And welcome to Schoodic Institute. My name is Mark Berry. I'm the president of Schoodic Institute at Acadia National Park. My pleasure to welcome you all this evening and to introduce our speaker and our program. Before I do that, we have a range in our audience tonight in terms of your familiarity with Schoodic Institute and what we do. We're a close nonprofit partner to Acadia National Park that is dedicated to advancing ecosystem science and learning for all ages. And we often work at the intersection of those two things, seeking to engage the public in the scientific process, both for a better outcome for the science and a better outcome as a learning experience. But we have a wide range of research programs and partnerships and a wide range of learning programs and partnerships from youth through all ages. And I hope you will take a continued interest in this work. We feel it is of great importance to fulfill Acadia's original vision as a park that was of great interest to science and that was intended to serve to inspire others and inspire conservation elsewhere, in addition to protecting its natural and cultural resources for us and future generations to enjoy. And as the park is now entering its second century, we are looking ahead to the next 100 years, thinking about what will be necessary in the face of a great many rapid environmental changes, one of which we'll hear a little bit more about tonight. So if you are interested in Schoodic Institute, follow our website, schoodicinstitute.org, our social media, Facebook, Twitter. Sign up for our email newsletter, which you can do on our website. If you want to pick up a 2-paragraph summary of who we are and our contact information, those are on the table outside. And I also want to mention, before I do my introduction, the art exhibit that you all walked through and passed on your way into the auditorium. We are hosting through the month of August. If you wanted to bring anyone else back to see that, there's an opportunity to do so. The artist is Duncan Martin. He has connections in the Blue Hill area, but his project that's exhibited here, and this is the first exhibit of the project, is 58 works from 58 national parks in 58 months. So he traveled throughout the entire national park system, including some of the most remote units of the park system in Alaska, worked in the field on the smaller paintings, and then created the larger works in the studio. And although they are not all individually labeled, each is from a different park, and there is a list available also on the table near the front door. So if you want to enjoy the process of trying to figure out where things are from, you can do that, and I could probably help you with it if you want after our talk tonight. So with that, I'll turn to my introduction. You can see on the screen behind me that our speaker is Trina Wellman. Trina has received a master's in marine policy and a PhD in natural resource economics, both from the University of Washington out in Seattle, and has worked for the National Oceanic and Atmospheric Administration, the Battelle Memorial Institute, and the Woods Hole Oceanographic Institution before taking her current position as an associate at Northern Economics in Seattle. She has a close tie to the Sorrento area, which is why we have her presence gracing us this evening, and looking forward to hearing her talk about ocean acidification, and in this case, its effects on human communities. And there'll be time for questions and discussion afterward. So with that, Trina, thank you.
I just want to thank you all very, very much for having me here this evening to talk. I'm also a Bangor-born girl, so I have real ties to this area, and it's a real pleasure to be able to come and speak to you all about something that's actually very near and dear to my heart. So what I'm going to talk about today is ocean acidification, and we heard a wonderful lecture last summer by one of the resident scientists, and he talked more about the physical impacts and the chemistry of ocean acidification. But as a social scientist, and I know we have at least another social scientist in the audience, I'm going to focus more on the impacts of ocean acidification, or OA for short. I'm going to talk about the impacts on people, and specifically members of the shellfish industry. So the project that I worked on was collaboratively funded by NSF and the Socio-Environmental Synthesis Center, which is in Annapolis, Maryland. And so a group of us from all over the nation met 4 times each year for 2 years. And our group was led by Dr. Julie Ekstrom. And Julie is now at the UC Davis Policy Institute for Energy and the Environment in California. And unfortunately, that's kind of a long distance for Julie to come, so she talked me into doing this presentation in part for her. It was a very interdisciplinary group of researchers. We had oceanographers, biologists, geochemists, and I was the economist on the team, and then we had a lot of policy experts as well. Our paper or study was published, if anybody's interested in looking at more in detail, it was published in February last year, 2015, in Nature Climate Change. That's the journal. So I'd like to begin by just sharing with you the motivation for this study. And I know some of you know about this already, but I'll run through where this all really started. So in the summer of 27, Susie Cudd's baby oysters in their hatchery in Whiskey Creek Shellfish Hatchery in Oregon, all of a sudden she noticed that her larvae in her hatchery were, all of a sudden they stopped growing and they would just die. And they suffered at that point an 80% mortality in that hatchery, which is really significant in the Pacific Northwest in particular because most facilities, farming facilities, aquaculture facilities, now rely on hatchery seed because the natural stocks sort of ebb and flow, that sort of seeding naturally. So this episode, that particular summer, cost over $110 million to the Pacific Northwest shellfish industry. So through partnerships with scientists in the area and also with a number of the local fishermen or shellfish fishermen and farmers, they were able to determine that ocean acidification was in fact what was causing this massive die-off. So what was happening in this particular part of the country is there was a huge upwellings right off of the Washington and Oregon coast. And with that upwelling that happened that summer, it brought all this highly acidic water that was normally kind of down low in the water column. And so it was what was coming up, and it was so acidic that the poor babies couldn't survive. So where this all comes from is when CO2 dissolves in the ocean, it actually triggers a chemical reaction that reduces pH of water and increasing its acidity, and then it also reduces carbonate, and I'm not going to go into the chemistry of all of that, but carbonate is what's crucial to shellfish and corals for building their shells and their skeletons, and with less of it, what happens is organisms spend all their time trying to grow shell, and then they forget to feed, and that's what causes them to perish. So in the Pacific Northwest, the shellfish industry has actually made really great strides in dealing with this catastrophe that happened in 27. 2 of the hatcheries actually built secondary hatcheries in Hawaii where they didn't have to worry about this acidic waters. And then another hatchery, Taylor Shellfish, which is very widely known, particularly in the West Coast, they're treating their water using a pump that continually monitors the waters that's coming into their tanks. And it will then tell them when the acidity levels are starting to go up, and then they just pump in sodium carbonate or just soda ash, and then that helps bring the pH back down again. And Bill Mook down in Damariscotta is doing something really similar already because, as you'll see, there's some significant issues in Maine. But this experience in the Pacific Northwest basically sent a shockwave through the whole United States. And shellfish growers and farmers all over were getting very, very worried. Yet there was really very little understanding where this acidity issue would show up again, what parts of the country, how resistant communities could be, and what could be done to reduce the risks. And so this sort of, the way we saw it is the emergence of a real economically measurable human impact from OA really sparked all sorts of interest in regional responses of how to deal with the OA and working at the same time ultimately on global solutions to reduce carbon impacts to begin with. So this is what prompted our group to conduct the study I'm going to tell you about, and we call the work we did a local level vulnerability assessment. And in our case, we focused explicitly on shellfish industry and the coastal communities who rely on those industries. So the questions we asked ourselves, basically with an underlying assumption guiding the assessment that in addressing existing vulnerabilities, we can help reduce vulnerabilities from ocean acidification in the future. Have communities ready to be able to deal with this issue going forward. So the first question is, where should we be focusing attention and research and monitoring regarding OA and its impacts on shellfish? And the second is, what can communities do to minimize the harm to their industries and livelihoods? And third, are we conducting the necessary research to prepare these communities for potential impacts? So, as I said, we did this vulnerability assessment, and vulnerability assessments are pretty standardized now in the literature. But what I want to start off with is to emphasize that we did our work solely on shelled mollusks industry, including clams, oysters, mussels, and scallops. And we did this because the current scientific literature suggests that this taxon, broadly speaking, is one of the most sensitive groups to ocean acidification. And so we view our work as just really the beginning of more research that can be done in this area as we learn about more other vulnerable species. So we had three components to our vulnerability assessment. You'll see the hazard of ocean acidification, so the hazard. And then what we call sensitivity, and the sensitivity we measured using economic dependence. And then adaptive capacity, and there we have, I'll tell you in a second, indicators that sort of suggest whether a community has or a region has what it needs in order to adapt to this changing situation. So the first component, again, the hazard. Oceanographers from Woods Hole Oceanographic Institution and NOAA evaluated exposure to OA to shellfish as the projected year in which the mean annual sea surface will exceed an empirically informed absolute aragonite saturation, and aragonite is what measures the carbonate. So in addition to that, we know from the natural scientists that in addition to just the influence of CO2 and seawater, we have upwelling of currents, and that's what happened in the Pacific Northwest. The water was all down there, and it was all just fine until this surge of upwelling occurred. In addition, nitrogen-induced algae or eutrophication actually enhances acidification. And lastly, river water chemistry. A number of the rivers around our country we've discovered have very low aragonite saturation states. So those are all additional factors in addition to the influence of CO2, which are global models. And I'll show you an illustration of that in just a minute. So our economic dependence or sensitivity, we looked at a cluster of coastal communities all around the United States using an index for economic dependence. And our indicators there were looking at the total value of shellfish harvest in that region, the number of jobs that are created because of the industry. And we used, because we actually couldn't measure that and it's not data that's collected, we used the number of licenses that, as a proxy. And then in addition to that, we looked at the percentage of total revenues in an area, total revenues from all fisheries that are shellfish. And I can show you an example as we get to Maine. And lastly, this adaptive capacity. Oh, and before I mentioned, those three different proxies were then turned into an indicator. And so we had an indicator of 1 or 0 or whatever. So the adaptive capacity, we looked at whether there are alternative job options. Are there alternative job options within the shellfish industry or within fisheries or alternative employment? We looked at scientific capacity. Does the region or the area have a sea grant that has a budget to help with outreach and education? Are there marine labs in the area where there's collaborative work with scientists? And so here's a great example at the Schoodic Institute that here is an asset to our Down East Maine. And then the state's preparedness for dealing with OA. So has there been any legislative action? In the Pacific Northwest, once we had the 2007 incident, our governor started a blue ribbon panel on ocean acidification, which is now ongoing and doing lots of monitoring and research. And whether there's any sort of climate adaptation plan. Many states and regions do have such a thing. And in fact, Maine is on its way. So these, again, were all combined into a single indicator. So from a data perspective, what we did is we created maps of all the data that we collected around the United States. You'll see here I've just sort of focused on the East Coast for now. But so we mapped that very first one is the ocean locations experiencing the most rapid change from rising CO2. And then we added in those factors for the other factors enhancing ocean acidification. And then we mapped those communities that are most vulnerable to ocean acidification as related to the shellfish industry. So here's just a little close-up of, oops. Oh, no, that's fine. So here is what the global models tell us about where we will see ocean acidification in terms of timing. So you'll see the very dark, almost really red. So it's saying that up in the state of Washington, we're going to see it, we've already seen it, and up as far as 2030. And then we have that little corner in down East Maine, which is also highly, highly sensitive. We're probably going to see really significant impacts from ocean acidification somewhere between 2031 and 2050. So we're not talking that far out. But knowing these kinds of things, people can start to think ahead about how are we going to adapt to this changing climate situation. And you'll notice that Alaska is highly significant. But what's interesting in Alaska that we discover is, of course, Alaska is not highly dependent on shellfish or mollusks as an industry. So as a result, you'll see that Alaska doesn't turn out to be one of our hotspots because of the way we did this particular study. And as I go through, you'll see why that's so. So you do see that, generally speaking, that ocean acidification is probably going to reach the northern coastlines sooner than some of the other areas. And the reason is because the water is colder. And CO2 dissolves in water holds more CO2, cold water holds more CO2 than warmer water. And so that's why you're seeing those hotspots. Okay, so one thing that there's just pointing out those hotspots. Okay, so I talked about those local risk factors. And so these global models don't predict anything in the near shore and the estuaries. So what we did is we added in that data. So the blue triangles are showing areas of low pH or low carbonate rivers entering into the systems. And you start to see how Massachusetts and then down in the southern eastern seaboard states, that's a significant issue. And then if you add in the eutrophic estuaries, look at where at the mid-Atlantic, all of a sudden, there's a much more significant impact from OA than one might think, just because of these other factors. And then the upwelling currents is all on the Pacific Northwest, so I didn't put that into the picture for now. So in terms of our economic sensitivity, here's we mapped those social factors that I mentioned. And you can see the pockets of high economic dependence on shelled mollusks on all coasts. So Pacific Northwest, the Gulf, Mid-Atlantic, and then look at our dear state of Maine up there. It's pretty significant, particularly down East Maine. So there's a high level of dependence on those areas, or economic dependence on shellfish. So here's just a close-up of Maine. The top, the years, show you the locations using just those ocean models of where we'll see OA having impact sooner. And you can see that up in that very eastern part, it's pretty significant. And then the orange shows you where all the shellfish harvesting is happening along the coast, and it's significant, and it's our whole coastline. And then the brown colors on the shore base, that's basically looking at sensitivity. So again, you'll see that very high sensitivity in that part of Maine. So you start putting those things together and you get a much better picture than just looking at those global models and the data that they report. So then lastly, we looked at adaptive capacity. And what's really interesting here, and I'll tell you a little more for those that don't know, that Maine is actually in a pretty good shape, and I'll talk about it in a second. And you'll see that Washington and Oregon are doing very, very well. They're at the highest level of adaptive capacity with lots of opportunities to either diversify the jobs or the industries, but mainly I know for a fact in Washington State, it's because of all the work that's already been done at the state level and all the research going on in the universities in the area. So I'll come back to that adaptive. And you'll see, again, places like Alaska in that little part just east of the Bering Sea, you can see where they're sort of medium, but that has to do with they do have fairly good research programs going on at the state there. But you'll also see that there's very low adaptive capacity in the Gulf. So if you put all this together, you can see the mosaic of vulnerability around the United States. And so, again, the coincidence of high exposure from OA, low adaptive capacity, and high economic sensitivity, those are what we were looking for. Where are these hotspots? And so you'll see we have a New England hotspot. We have, and then I guess what I was going to add here is when you start adding in the rivers and the eutrophic estuaries and the upwelling, all of a sudden a lot of the vulnerability looks totally different because you've added that whole other factor of ocean acidification. And then the upwelling out on the Pacific coast. And then down into the Gulf, all of a sudden the whole vulnerability analysis shifts because they have such low adaptive capacity. And then they have all the issues associated with river low aragonite saturation states. And so it's really shifted everybody's thinking about where we need to really be focusing in the future in terms of policies and management and adaptive measures. So one of the things that we also found as a major observation of our work is the unique profiles of the different regions in the United States. And because of that, there's a real nuance in how each region is going to have to come up with its own sort of best recipe for future proofing against OA. And so you'll see there's the example of Susie and their challenges are the northern water, upwelling rivers, but they have these assets. They've got a lot of aquaculture going on there, multiple species for some diversification, and they have very active state government and participation partnerships with a lot of local scientists. You look at a place like in the mid-Atlantic, and their challenges are the rivers, it's the eutrophication, it's low commercial shellfish diversity, those are all their challenges, but they have an asset of local pollution controls. So you'll see that it's totally nuanced as to what you're going to consider doing where. So why is Maine the hot spot? Again, I've sort of said it already, but there's a significant economic dependence. And there's $20 million annually is the output or production of clams, mussels, and scallops in the state in just down East Maine, not even the whole state, just down East Maine. And coastal Maine supports thousands of shellfish fishermen in terms of jobs. Down East Maine alone supports over 2,000 fishing licenses. And to date, there's about 57 different aquaculture sites along the coast and about, 19 experimental shellfish aquaculture ventures. And the Maine economy really relies heavily on shellfish, especially since the 1980s and 1990s cod stock bust. So there's a lot less, resource out there for individuals to base their industry on. And again, I said the Maine waters are cold, and so that's trouble. In addition, there are rivers, and it matters because we have a lot of flowing rivers, or rivers flowing into our waters that are acidic. And then pollution basically sours the waters as well. One of the issues we face in down East Maine are leaking septic systems and the impacts in some of the farming that has poor nutrient or pours excess nutrients and nitrogen into the waterways, also raising acidity. But the good news is that Maine has already really been thinking about what they're going to do here. So obviously, what you'd like to do is reduce marine ecosystem exposure. I mean, that would be the ultimately best thing to do. But in the shorter term, we want to reduce that social vulnerability. So diversifying shellfish portfolios. I think one of the things that I've heard is an encouragement to actually do more shellfish aquaculture where you can actually work on the larvae in situ, and so you can buffer the water and make sure that those little critters grow to the size that they can then continue to grow naturally. So there was a workshop held in October 2014. It was called Increasing Community Resilience to OA in Maine. And they came up with a whole host of really, I read through their document, a whole host of very interesting recommendations to address OA. They're looking at things like local, non-regulatory approaches that basically draws on Maine's collaborative and innovative nature in general. And it's also recognized that Maine's comprehensive planning at the municipal level provides lots of opportunities to make changes that would help to address OA. I mentioned the example of encouraging more aquaculture. The Maine has also already assembled an expert commission to study the impacts on the state's commercial shellfish harvest, and they've actually issued recommendations in 2015 that what we really want is for the state policymakers to take them very, very seriously, because unless they take it seriously and none of those suggestions or recommendations are taken into account, we may be facing a disastrous situation. So getting close to the end, I just wanted to point out some limitations and opportunities from our work. One of the biggest ones was the real gap in the marine ecosystem exposure data, those big global models that scientists have been developing. And we're not totally sure on which ecosystems and which oceans are most susceptible to OA. We saw the maps of the work that has been done, but it's not been completed around the United States. The thing that was most important to us as social scientists is we had no high-resolution data on the full cultural and social significance of shellfish to communities. So we didn't have any data on human nutrition from shellfish, shoreline protection from shellfish beds, water filtration from shellfish, and tribal culture uses. And in the state of Maine, that's really important because these people have counted on shellfish for, it's part of their heritage, it's part of their diet, et cetera, et cetera. So the incorporation of these other, this is the jargon, ecosystem services, aside from economic that we've talked about, these services that are provided by shellfish, if we had data on that, it could totally alter the vulnerability landscape that we see, because those are very important contributors to social and cultural well-being. So just by way of a little cartoon, so here's an example where, say there's no shellfish, they're all gone, there's a dead one right there. But we know we get nitrogen and phosphate into the system, we know we get plankton, we get these plankton blooms, and then of course once there's a bloom, there's a die-off, and with the die-off, it takes up oxygen, which is the hypoxic situation, and then there's just all this decay, and it creates this eutrophic situation, or low anoxic conditions, and loss of habitat for some species. And at the same time, it impacts and shades submerged aquatic vegetation, and then leads to die-off of that vegetation, which also leads to losses of spawning and nursery grounds for fish and other species. So that's the condition without shellfish. But if you put shellfish back in the equation, and they are growing and producing, et cetera, you can still put in that same amount of nitrogen and phosphate, but what happens is the shellfish will actually eat some of the plankton as well as take up a lot of that nitrogen and phosphates which they store in their shells. So when you harvest that shellfish, you're actually doing something very good for water quality. So you're cleaning up the water. You now have a situation of there's enough oxygen. You've got oxygen-rich conditions, good survival for fish species. And it also implies that there's less impact on submerged aquatic vegetation and maintaining a healthier ecosystem generally. So that just is one example of if we had that kind of information, it would dramatically change, I think, what our vulnerability landscape looks like. So just by conclusion, I think it's clear that there's some issues for the state of Maine in the future unless vulnerability is taken into consideration and alternatives to deal with that vulnerability. This framework that we developed really helped us structure our thinking about ocean acidification and how it affects ecosystems and people. It also helps to identify and organize, as I mentioned, these suite of opportunities to deal with these challenges that are nuanced across our country. And lastly, I think it's important to remember that regional and local actions are vital in this situation, but they're going to need to be supported by resources and monitoring and coordination and guidance at the national level. So there is quite a bit of discussion in DC now about how we're going to deal with this going forward, and we're just grateful that our work has been taken into consideration at that level. So with that, I am going to say thank you. If anybody would like to get a copy of the paper, I can do that. And then I am happy to take questions, but we also have a snack, thanks to Waukegan Neck Oyster Farms. So I'm happy to answer any questions if I can. There may be some that I can't answer because I wasn't on the natural science side of the work. Thank you.
Thank you, Trina. And as questions come up, I'm going to run the microphone to you. I know some people can be loud, but we're also recording this, and it works much better if you put this near your mouth.
I just had a question. You showed that national map, which showed big gaps for the border of Canada. Are the Canadians doing anything with this? Or?
The Canadians are just starting to get worried because they've seen what's happened in down here. They're particularly getting worried up in Prince Edward Island because they have large aquaculture facilities up there and lots of shellfish industry happening. So on the west coast, in British Columbia, there's a lot less shellfish harvesting going on, and their aquaculture is limited. So that coast wouldn't be as vulnerable as it is on this coast.
I got one more.
Yeah.
What do you know about OA's effect on sea vegetables?
You know what? I forgot to mention something really important. I'll come back to sea vegetables, but I forgot to say and talk about the fact that lobsters weren't included in our study. It's still out for discussion. One study has said that lobsters are highly vulnerable. Another said they're highly not vulnerable. And then there is a study that's just been, they're still working on it in Lubeck, and what they have found to date is that lobsters are only moderately vulnerable, but sea urchins are highly vulnerable. And so if you added vulnerability of lobsters into the equation in the state of Maine, you know, that becomes really serious because of the economic dependence on that part of the industry. Sea vegetables, we looked into, not in the United States because we didn't have any information about it, but there is some concern in Ireland about the impacts of ocean acidification on theirs, because they're doing a lot of seaweed aquaculture. And so they're monitoring the waters and they're just trying to keep track. But I think that industry is so in its infancy that there's not a lot of research on it yet.
I have a question. So I'm lucky enough to live in Damascata and actually know Bill Mook and Dick Klein, if anybody knows Dick Klein. I had his kids in school. I'm a public school teacher. So my question is there any work being done on the genetic side? Like you had a 20% survival rate out in that sample out on the West Coast. Is anybody looking at the genetics of those particular babies that survived and then working magic with that particular?
Yes, and in fact, that was another point I forgot to mention, that there is research going on right now to see if they can genetically modify the oyster, they're doing the work on oysters, and to see if they can genetically modify them to be able to adapt to this more acidic water. And again, that predominantly impacts any natural shellfish or oyster beds, less so than the hatcheries and the businesses that own their own hatcheries, because they've dealt with that situation in situ, but in nature, not as easily done. But yes, I know there's work being done at the University of Washington, University of Oregon. I think somebody's doing a little bit of work at the University of Maine. So I've heard a couple of talks, so I know it's happening. I can't tell you anything more about that.
Perhaps while someone's... I'm going to cut myself off and go to the question.
I have a question related to prevention of the issue. What type of, we're from another state, we're from Connecticut, and our impression in Connecticut and in public health is that Maine is pretty good in the area of public health and preventing things such as nitrogen and phosphorus pollution due to septic systems. Mm-hmm. What kind of, and even wetlands controls, but what kind of legislation do you think is necessary to help address the issue of acidification in general?
Of the more coastal-based acidification,
sure.
Or the shoreline-based?
Yeah, like, well, in rivers, in
right.
particular, rivers going into.
Right. Well, I know in Connecticut, actually, because we did a study in Long Island Sound on the oyster industry, that they are putting in best management practices for agriculture. They're putting in the sewage treatment capacity. They're always working on developing that. But the interesting thing that they're doing in Connecticut, they're looking into the possibility of expanding the shellfish aquaculture to help do a lot of the cleanup. And there's some talk about, and this is through work with EPA, they're talking about building a trading program, not just across wastewater treatment facilities up the Connecticut River, but adding these oyster farmers and harvesters, adding them to the trading system and giving them basically credit for the fact that when they're harvesting their product, they're removing a lot of pollution from the water. So that's something that's in discussion, and I don't know where it's gotten. Our paper just came out just recently. And so I think that's a really interesting, intriguing idea, and I know they have started doing that in the Chesapeake Bay. So what they're trying to do is say, okay, well, we've got this thing that's helping us clean it up, and we're running out of sewage treatment capacity, so maybe we add them to the mix. Yeah.
I have a question due to the genetically modified shellfish. I was just wondering if they have considered the effects it will have on the predators that eat these shellfish and the humans that also eat it. Because my mom, she services gluten-free, and she knows that this is due to some allergies of genetically modified food.
Right. So it technically, ocean acidification wouldn't modify the product you consume, because ocean acidification affects the shell. It doesn't affect the critter, but the critter dies because it's working so hard to produce its shell, and it stops eating, basically. So that probably, I wouldn't think would be an issue. And then you had a second part to your question. It was,
if they decided to genetically modify the oyster to make it non-vulnerable.
Got it. Again, that would be a modification to how it grows shell. And so it would be more about the chemistry of what it needs to grow shell rather than the critter itself. And then of course, mostly it's an issue of Vibrio and other pathogens that are of concern to individuals. And they are in the labs looking at ways to figure out how to deal with that as well. And I was talking actually to Jock Crothers about it and what they do here locally. And I know in Washington State, where I live in the winter, they now have to monitor continually for temperatures and salinity. And when the temperature goes up, I don't know what the temperature level is, those beds are all shut down. And I was sitting next to a grower at a conference one day, and he kept looking at his phone. I'm saying, what is he looking at? He was checking to see when it was going to rain. Because as soon as there's rain out there, and then all the runoff just pours into Puget Sound, and so they try to get out there and harvest before they know it's going to rain, because they get shut right down. Yeah.
Well, what's your impression of how the fishing community in Maine is responding to this threat? Or I noticed that they had an item in the fishing convention in Rockland and so on. Just in general, how they're responding.
Well, my sense is they were very, very engaged in the workshop that they had at the Island Institute. And so in reading through, you can see lots of comments, ideas, thoughts from the fishing community. So they're being very thoughtful about this right now because they see this as a threat. And I've gathered that the collaboration between the scientists and the fishermen and the policy people has really been quite good to date. So is that answering your question?
Well, I think I will jump in here. I want to acknowledge a couple other aspects. One is one of our staff people who's here in the back. I'm going to ask you to wave your hand, Hannah. Hannah Weber is Education and Research Project Manager for Schoodic Institute, who's our lead person working on issues related to ocean acidification and a lot of other projects as well. But she's working right now with a team of volunteers from Earthwatch, many of whom are in that part of the auditorium. Maybe you can wave your hands as well. And we have a number of teams that come through over the course of the year. And one of the researchers that they work with, one of the projects they work on is looking at ocean acidification in the intertidal here and its effect on intertidal communities. Hannah has also been the lead on installing a new piece of monitoring equipment just a month or so ago off Schoodic Island, which is continually monitoring pH, temperature, salinity near the edge of the eastern Maine coastal current. And it's only the third such fixed system in the Gulf of Maine. The other two are at the far southwestern edge of the Gulf of Maine. So those are a couple of aspects in which Schoodic Institute is directly engaged in ocean acidification research, but there are a number of other ways that we're participating in broader collaborations, and Hannah would be a good person to grill with further questions as we enjoy a snack, unless Jock wants to ask another question first.
I was just curious where we can find that data.
So we just have to go
The new unit is not transmitting data in real time. It's on the seafloor and does not have an antenna. So the data will come occasionally. Yeah. So with that, I think the snack will be back out in the lobby for those that are interested in partaking. And thanks again to Trina, and thanks to all of you for being here this evening.